Three things today. We're going to first simplify rational functions, and we'll multiply, divide. When you are simplifying fractions, there's two types where you can have either just, this is a term over term. See how there's no adding and subtracting on this one? And in this one there is. There's some adding and subtracting. Okay? When there's two different types how you simplify. When there isn't any adding and subtracting like this is when you just simplify using your exponent properties. So remember when we are, see how I have x's? When we're dividing same bases, what do I do with the exponents? You subtract. So I'm going to have 3 minus the 1, which is 2x squared. And then if I look at my y's, I have a 1 here, so 1 minus 3 is a negative 2, but can't have negatives, so you put it on the bottom as y squared. Or the easier way is to think if I have 3 x's on top and 1 x on the bottom, I have 2 more x's on top. If I have 1 y on top and 3 y's on the bottom, I have 2 more y's on the bottom. That's kind of what you're doing. And then, of course, you have to simplify. Negative 5/15 simplifies into what? 1/3. So I would have 1. You can write the 1 there. You don't have to. And then you put 3 on the bottom. Okay, so technically you wouldn't write the 1, but it's fine if you do. Once you have it simplified then, you need to define your domain. That's what it says over here. State what x cannot be. So when you're doing that, you go back to your original equation here. What would make the bottom 0 if x was what? If x was 0, my denominator would be 0, right? Because I would have 15 times 0 times y cubed. So we'd have to say x cannot be 0 and y cannot be 0. Because what if y was 0? I would have 15 times x times 0 cubed, which is 0. So you have to define, once you have it simplified, you have to define what x and y cannot be. Say this is what it is as long as x and y aren't zeros. Look at the one below it here. This one has adding subtracting. That means it's a polynomial, not just one term. This would be a binomial. So this is where you have to start factoring, and whenever I have two terms like this, I look at both terms and I think, okay, what can I factor out of both terms? A 3 and a c. So what's left in the first term, 2c. What's left in the second term, just a 3. Okay. Now you should notice that you can cross something off. I have a 3c on top, I have a 3c on the bottom, they cross off, so this just simplifies to 2c plus 3. And this is fine as long as c does not equal what? 0. C could not be 0 because that would make the bottom 0. So C cannot be 0. Again, I need to first factor. You're always going to factor first on all of these if possible. The top is just 2x, so I look at the bottom and I look at both terms. What can I take out of both terms? A 2 and an x. So I'd have 2x left in the first term minus 1, right? If you take everything out, there's always a 1 left. What can I cross off? 2 x's, very good. There's a 1 left on top. Okay, even though I crossed everything off on the top, there's still a 1 there that you put. And then it'd be over 2x minus 1. You can, and then, right, so you see a 2x here. This 2x cannot get crossed off with this 2x because this is part of a polynomial. It has to be, see how I'm multiplying right here? So this is just a term by itself. It's not adding or subtracting to anything. So that's crossing off with this one. Okay. So then x cannot be, I have two options now. X cannot be 0, because that would make the bottom 0, or x cannot be positive 1/2. Right? And how do you get those? Here's are my two parts, right, that I'm multiplying together. So I set 2x equal to 0, and I set 2x minus 1 equals 0, and I solve both of those. So you can look at them and do mental math and know 0, 1/2. If you can't do that, you'd actually have to go through and solve and say, oh, x cannot be 0. What else would make the denominator 0? Divide by 2, and then you see, oh, it's 1/2. Okay, so if you can't see it, you'll have to use your algebra to find out what x cannot be. Okay. Let's try the one below it. Again, we need to factor. How do I factor the top there? Do you guys see how to factor the top? I'm subtracting two terms, and both of these terms are perfect squares. So this is factoring difference of squares. So this would be 7 plus z, 7 minus z. Okay. If we get into factoring today and you're not quite sure what I'm talking about, that YouTube video of how to factor is still online. Maybe we need to watch that again and like, okay, what are all the factoring ways? How do I factor? You'll have to refresh on that again. Because this is called difference of squares. Whenever you're subtracting two perfect squares, what squared is 49? 7. What squared is z squared? Z. So it factors into 7 plus z, 7 minus z. Okay, that's called difference of squares. Do you see what I can cross off? Z plus 7. Yep, these are, even though they're in different order, these are the same thing. So those cross off. So it simplifies 7 minus z, as long as z does not equal what? Z cannot be negative 7, because what plus 7 would give me 0? Negative 7. My first step, let's factor. This is 3 terms, it's a trinomial, so this is where I say, okay, what do I multiply equals 16, but add equals 8? 4 and 4. What do I multiply equals negative 24, but add equals negative 2? Negative 6 and 4. Good. Now that it's factored, what can cross off? The x plus 4 is very good. So this simplifies what's left on top, what's left on the bottom. Right? So it simplifies into that. But then I need to define that answer and say x cannot be 6 and negative 4. You have to go back to your original denominator before you cross stuff off. And x cannot be 6 and negative 4. One more simplifying here. When you have the order backwards, I would suggest flipping the order around. It'll make it easier to factor. So I'd go negative x squared minus x plus 12. And then make it even more easy by factoring out a negative to make that x squared positive. Okay. By doing those steps, we can now just do the factoring question, where I say, what do I multiply equals negative 12, but add equals 1? And what would that be? Yep, x plus 4, x minus 3. And then I'm down here, what do I multiply equals 12, but add equals negative 8? Okay. So now I'm looking, what can I cross off? What's the same? X minus 3's cross off. So this simplifies, I still have that negative there, don't forget the negative. Negative x plus 4 over x minus 5. And I still need to define, so I look at my original denominator. X cannot be 5 and 3. Just like simplifying, multiplying is very similar. And again, there's 2 types when I just have a term, right, on each one, or if I'm adding and subtracting and I have polynomials on each one. Okay, when you have terms like this, it's easier to multiply first and then simplify. Okay, So to multiply, remember how to multiply fractions? You just multiply the tops, multiply the bottoms. So I'm going to multiply first. So 4 times 7 is 28. And this would be x squared y. And then I'd multiply the bottoms together. 5 times 12 is 60. And then the bottom would be, variables would be x to the 4th y. Okay, see how now I have it into one term so it's easier to look at? Okay, so right, when I'm dividing same bases, I subtract, which you should be able to see with my x's. I have 2 more x's on the bottom. I have 2 x's on top, 4 on the bottom, so that means I have 2 more x's on the bottom. Y's are just going to cancel out because I have 1 y on top, 1 y on the bottom, so those just cancel out. And then I need to simplify 28 divided by 60 simplifies into what? Well, 28, 60, let's see, 14 over 30, which would be 7 over 15, right? If I just divided in half and kept going. So I would have 7 over 15x squared. That would be simplified. But I still need to go back and say x cannot be 0, because that would make the denominator 0. And y cannot be 0, because that would also make the denominator 0. On with polynomials, when you have polynomials, just like simplifying, your first step needs to be factoring. You have to factor first. Okay? So what am I going to factor on this top here? What can I factor out? A 4. Factor out a 4 and I get 2y minus 1. What can I factor out of here? A 5, and I'd get 2y minus 1. What about here? A 5, and I would get y minus 3. And what about here? A 3, and I'd get y minus 3. Okay? Once everything's factored, here's the rule. When you're multiplying, as long as it's on top somewhere, doesn't matter where, and on bottom somewhere, they cross off. So they don't have to be the same fraction. They can be different fractions as long as one's on top and one's on the bottom, they cancel out. So it doesn't matter where it is, as long as one's on top and bottom, it cancels out. This one worked out where, yep, that cancels out and that cancels out. What else cancels out? Do you see it? The 5s. So this simplifies into what? 4/3. That's nice, isn't it? 4/3. But y cannot be what? Y cannot be 1/2. If I set this equal to 0, I would add 1, divide by 2. So y cannot be 1/2, and y cannot be 3. So again, this, see how there's no adding, subtracting? So this, we're just going to multiply first, then simplify. Okay? So multiply the tops. 2 times 5 is 10, and I would get x to the 4th y cubed. The bottom would become 40, and I would have x cubed y to the negative 2. And remember, when I'm dividing same bases, I subtract exponents. So 4 minus 3 is 1, so x to the 1st. 3 minus a negative 2 is 5, and then 10/40ths reduces to what? 1/4. So if you put a 1 there, that's not wrong, but technically we wouldn't put a 1. We would just put a 4 on the bottom. And then, yep, x cannot be 0, and y cannot be 0. Okay. Technically, y could be 0, I guess, because y to the negative 2 would actually be on top as y squared. But, yeah, technically it'd be fine, but if you put y cannot be 0, I wouldn't count it wrong. I'm not going to be that picky on defining. One is polynomials. So we factor. So I look here, what can I factor out? A 2, very good. I look at the bottom, what can I factor out? 3. I look over here, what can I factor out? 2. Good. And I look here, what can I factor out? Nothing, right? 3 and 8 doesn't have anything in common. Okay, now look, what crosses off? X, all right, very good. I can make these two the same, right? Right now they're exact opposites. This is a positive x, that's a negative x. This is a negative 3, that's a positive 3. So the magic trick in math is if I take out a negative, I can change both of those signs. Now they match. Now they're both x minus 3's, and I can cross them off. Anything else I can cross off? Is there a 3 on top anywhere? Nope. Is there a 2 on bottom anywhere? Nope. Okay, so what's left on top, I would multiply negative 4x plus 6. You guys see how I got negative 4? Because you'd multiply that. And then I would have 3 with the 3x plus 8. Okay. You can remultiply, but I would leave it because this sets us up now to find our asymptotes. So I tell my students never remultiply, just leave it factored because you need it in factored form to find domain, range, asymptotes, and all of that. So what x cannot be, look here, even though it crossed off, we still have to consider it. What minus 3 gives me 0? And then here, what would give me 0 here? Negative 8/3. Because if I set that equal to 0, I would subtract 8 divided by 3. Factor, and these are quadratics, so we factor. What do I multiply equals 6, but add equals negative 5? What do I multiply equals 2, but add equals 3? 2 and 1. This is a difference of squares. What squared is x squared? X. What squared is 4? 2. So this is x plus 2, x minus 2. That's just a form to recognize difference of squares. And then this one, what do I multiply equals negative 3, but add equals negative 2? Negative 3 and 1. Okay, so now, as long as it's on top somewhere and on bottom somewhere, you cross it off. So what do you see matches? The x plus 2 is good. What else? X plus 1s are gone. Good. What else? X minus 3s. What else? X minus, what happened? Everything crossed off, so what's my answer? 1. 1. There's always a 1 left. Remember that. If you cross everything off, there's always a 1 left. So 1 divided by 1 would be 1. Cannot be what? Right, we still have to define what x cannot be. So I look at all 4 things and say x cannot be negative 2, positive 2, 3, and negative 1. All 4 of those things x cannot be, because that would make all the denominators 0. So x cannot be negative 2, 2, 3, and negative 1. The thing about dividing fractions is what? How do you divide fractions? You remember? If you're going to divide fractions, what do? Yes, you flip and multiply. So really, I have nothing new to teach you with dividing, because dividing is just multiplying. You just flip the second fraction and it becomes a multiplication. Okay? So the only new part with these, we're to do exactly what we did before. We just have to add a step where I'm going to have 3x cubed over 5y squared, and it's going to become times 5x to the negative 5 over 6y to the negative 3. See how you just flip it? You've always flipped the second one. It's always the second one you're flipping. Then, this is where I was about 2 minutes ago. There are no adding and subtracting, so we are actually going to multiply these together. So this would be 15 x to the same basis. What do I do with the exponents? Add. So what's 3 plus negative 5? negative 2. The bottom, I would multiply 30, and then again, same basis, I add, so it'd be y to the negative 1. Okay. Then I need to fix the negatives and then reduce 15/30ths. So this x squared is going to go on the bottom to become positive. This y is going to go to the top to become positive. And then 15/30ths reduces to what? 1/2. So if you put the 1, that's fine, but technically you wouldn't. And then I would say x cannot be 0, y cannot be 0. Because I go back to the original and think, okay, x's and y's cannot be 0. And technically, I guess, again, it would just be the y. Let's factor. These are polynomials now, so we need to factor. So I guess it's up to you if you'd rather flip first then factor or factor then flip. It doesn't matter. So we can, I don't know, we can flip first. You guys want to do that? So this would be 3y minus 12, 2y plus 4, but then it's going to become multiply 8 plus 4y over 6y minus 24, right? You're just flipping the second one. And then factor. So what can I take out of 3 and 12? A 3. What can I take out of 2 and 4? A 2. What can I take out of 8 and 4? A 4. And what can I take out of 6 and 24? A 6. 4. Thank you. Okay, what can I cross off? As long as it's on top and bottom, it crosses off. Y minus 4s, what else? Y plus 2. Yep, even though it's a different order, they're still the same. It's positive y's with positive 2's. What else? Do you see it? I can take a 2 out, see that? Because 4 is 2 times 2. So I can take a 2 out and that becomes a 2. What else can come out? A 3, right? And that becomes a 2, but then what else comes out? The 2 is crossed off. So what do I have? 1. Everything crossed off. So it equals 1. But I do need to go back to the original problem. That's this over here. So maybe you would want to factor first. Y cannot be a negative 2. And y, I would have to look here. Y could not be, that would be the factor formed here, which is also a negative 2. So that's the only thing y can't be. So if you look at the, if you want this, the factored form, remember, is going to be on top up here. So y can't be negative 2. Example here. So let's flip first or factor first? Factor first this time, okay? What do I multiply equals 1 but add equals 2? 1 and 1. This is a difference of squares because x squared is x squared and 1 squared is 1. So this actually factors into x plus 1, x minus 1. Now, in order to divide, I need to flip and multiply. So my problem is actually this, x squared over times, this goes on top, and this goes on the bottom. Now, what's going to cross off? X plus 1s, what else? One more thing. And x is going to cross off because this is 2 x's and this is 1x. So this x is going to cross off with one of these x's. Right? So there's an x left. So what's left on top? X and an x minus 1. What's left on bottom? 3 and an x plus 1. First, I define x cannot be, I have to go back to the original denominator. X cannot be -1 and +1.